The final task in this 5-step plan is the application of loading. This is split into 2 subtasks: 1, the application of gravity loads, and 2, the application of lateral loads. The approach and method of application will be different for each. Following the completion of this load application step, we can begin initial analysis and design checks, starting first with the lateral stability workflow, which will be addressed in Module 4. It's important to note, although the model will be around 90% complete, we will revisit and continue to develop the analytical model as we progress through the modules. For example, this will include reviewing and amending element fixities, eccentricities, cross-sections, the creation of subsystems and load takedown workflows, and introducing further design elements. The design stage you are working to will influence the nature and accuracy of load application. We will cover both rapid global load application for fast initial analysis workflows for early stage design, and a more accurate application, in this case the replication of the prescribed loadings represented in the Stage 4 design documentation, as shown here with the example documented loading data for Level 0. You will try both methods as part of your familiarization, and are encouraged to use the Stage 4 loading plans provided in this module and apply these loads to your part model by following the guidance provided in this step. For further assistance and understanding, you can also open and interrogate the already completed part and whole models you downloaded earlier in the course in Part 1 of Module 2. Whatever design stage you are working to, the overall analysis and design template rules need to be followed. This starts with the correct assignment of loads to corresponding load cases and their actions. Refer back to the lessons on actions and basic load cases within the Analysis and Design Basics section in Part 2 of Module 2 for a recap. For a quick reminder, you can also observe the template load case rules in the loading legend as displayed here. We have a number of view options available to choose from when applying loads, whether 2D plans, 3D views, including specific filtered views, like this isolated slabs view. For gravity, area, line, and point loads, we will use either the Autodesk tools or the SOFiSTiK AMG toolset. AMG allows for rapid application, as we'll demonstrate shortly. To assist load application, load filters allow you to concentrate on one load case and load type whilst applying loads, keeping views clean in the temporary state. 2 primary methods are developed for you. These are 1. The SOFiSTiK Loads filter located in the drop-down submenu for loads in the Utilities section of the SOFiSTiK Analysis ribbon, and 2. Visibility of view filters in the various view templates within the Working Views section of the project browser. Let's begin by looking at both options for the application of gravity loads. Here we start with the project opened on the 3D analytical view. We'll also open the Analysis and Design, eLearning part model. First, we'll inspect the existing applied loads with the SOFiSTiK Filter Loads tool to familiarize ourselves with both this tool and the loading already applied in the model that you'll look to replicate as your e-learning exercise for this step. On opening the tool, we are presented with the loading that is visible in the current view. Selecting a load case applies a temporary view filter where only the loads of the selected load case are visible. Optionally, we can apply additional filters for the load type, i.e., point, line, and area. You can also select multiple load cases. To inspect these loads further, When clicking Keep View, we return to the view and use the global filter to select only the loads in the view. Whilst selected, if we apply the Isolate Element option from the Temporary Hide Stroke Isolate button, we apply a temporary view setting to isolate only the loads. Here we isolated the wind and notional horizontal loads. After inspection, we can reset the temporary view state. Returning to the SOFiSTiK Loads filter, we isolate and show the pattern loading. To reset the SOFiSTiK Loads filter, open and without selecting any load case, click on Keep View. As we generally apply gravity loads to slab elements, we can use the 3D Analytical Slab view to isolate for only these elements for an easier and cleaner exercise. We'll do the same for our in-progress model and first check our visibility filters are selected for loads in the view template. First, we'll apply area loading using the native Autodesk tools. Click on the Analyze tab and select the Area's Load tool, followed by the On Host option. In the Properties panel, select Load Case 2. We'll keep the default orientation to project and then we'll type in a negative value, as our global Z orientation is negative, and in the view, individually select the analytical panels to which you want to apply the load. You can't apply to loads to multiple panels in a single action with this tool. Next, we'll look at the SOFiSTiK AMG Loads tool. Let's filter our previously applied loads and delete them. Now select the Loads tool from the SOFiSTiK AMG panel in the Analyze ribbon. Following the prompts, SOFiSTiK defaults with multiple selection, so we can simply select all the panels we wish to apply loads to and then click on Finish. Whilst the loads remain selected, don't forget to change the load case and load value in the Properties panel. If you do, you can simply reselect all loads and make the changes you want. Now we'll look at the application of area loads defined by a boundary. Let's filter the previously applied area loads and delete. This is carried out in a 2D plan to accurately draw the load boundary. Returning to the Autodesk Loads tool on the ribbon, this time we select the Define Boundary tool and draw our boundary representing the loaded area. A very useful tip: where loads are not constrained on host, these can be rapidly copied level to level using the Copy, then Paste to Selected Levels option of the Paste command, selecting the levels you want to copy the loads to. Refer to Autodesk Help for further information on constraining loads. This common warning pop-up relates to loads that exist over the penetrations. We can ignore this and continue. For area pattern loads, recalling earlier lessons in Module 2 covering actions, load cases, and combinations, we have specific superpositioning combinations set up for both total load and separately for pattern loading. Here we have a view already containing variable imposed area loading according to the loading categorization. We will use these loads by duplicating them and assigning them as pattern loads with new categories. We'll now look at how we generate and control the pattern loading to align with the analysis combinations. In our 2D plan view, we'll first set up model guidelines and plan out our proposed patterning. Navigate to the Structure tab, and then select the Model Line tool on the ribbon. In the Line Style drop-down, navigate to the SOFiSTiK Temporary Line Type and select. We'll now use the Simple Line tool to draw on plan the pattern boundaries. Once these are defined, we're ready to duplicate and subdivide the existing area loads. The duplicated loads will be assigned load cases from load case 50 onwards. There is some automation in the process, so there needs to be a free run of load cases available to fill. We can see these by navigating to Load Cases and Combinations dialog in the Analyze ribbon, and the legend also acts as a reminder. To duplicate and subdivide, we use the Load Pattern tool from the Loads drop-down on the SOFiSTiK Analysis ribbon. Following the prompts, the tool asks the user to select the load, then model lines. Once done, we are presented with the SOFiSTiK Load Division dialog box where we will change the name to QK-Pat. We can see in this model there are already loads assigned up to load case 100, with the first load case available for this subdivision is 101. The program already knows there will be 8 divisions and will assign load cases up to 108. Press OK and OK again. Now we can see our new pattern loads and can inspect using the Filter Loads tool. We repeat the process with the next area load. We now have one final task to complete the pattern loading. This is to change the load actions. Refer back to Module 2 for the background and reasoning. On completion of the pattern loading, these can be copied to multiple levels in a few clicks if desired. The pattern loads are now created, with cases assigned. Note, we haven't had to consider any EN code prescribed patterns such as checkerboard patterning. The superpositioning task in SOFiSTiK will separately apply each load automatically and store the maximum superpositioned result for each load, forming its own envelope. These stored results will be further superpositioned with the total load and construction load combinations. This provides an overall envelope of analysis results required for the ULS and SLS slab design covered in a later module. Now, let's turn to line loads. Similarly, as before, select the Loads tool, but now the Line Load tool, then on Host. In this brief example, we'll apply facade loading to the perimeter edges of the analytical panels. Alternatively, using the Define Path option allows you to define free line loads, and in the same as we did with the area loads, this is best carried out on a 2D plan view. Next, select Load Case 3 and type a negative value as we did with area loads. Now we can individually select the edges we wish to apply the loads. Now, we'll delete these loads and repeat with the SOFiSTiK AMG tool. The view requires the line category to be visible. We can switch this on in the View template by navigating to the Model View properties and ticking the Lines category. In a similar manner as before, we can select multiple lines in a single action and repeat this action. Again, remember to change the load case and value before completing each action. Finally, we'll look at point loads and use the balconies as our example to apply some notional vertical and moment loads. Again, check the visibility state of the view before starting. Select Loads, then Point Load, then on End Host. Next, select the required load case and type in the load values required. The loads in this example are oriented to the global coordinate system, but you can choose your preferred approach. Optionally, we can create a group for subsequent copy and pasting as shown here. Copying and pasting is better carried out in a 2D view. For balconies, a local coordinate approach is preferred, especially when copying a group and reorienting the element to different elevations. You can now continue your learning by carrying out the gravity load application exercise on your part model in accordance with the load values contained in the documented load plans. Referring back to the introduction of this last step, recall the second task for load application is to apply the lateral loads. This will be carried out in Module 4 as part of the lateral analysis workflow. We have developed a rapid workflow to apply the lateral loads for both wind and the notional horizontal loads, or equivalent horizontal loading, depending on your preferred terminology. This quick overview introduces you to the first task to be carried out in Module 4. The workflow is comprised of execution of an analysis to calculate 3 sets of primary results data. 1. The center of mass and its location projected to each story level. 2. The story level forces throughout the structure. And 3. The summary of the basic load cases: so the desired percentage of self-weight, dead and variable live loads can be extracted and applied as horizontal components for the notional horizontal loading. With the assistance of a few specifically developed Dynamo scripts for this task, we will automatically generate an attribute member at the center of mass at each level in the model, and then apply point loads for both the wind and notional horizontal loading in 8 directions automatically to the attribute members. This workflow has been specifically developed to address the need to rapidly apply lateral loading, saving valuable time and effort over a manual alternative. This now concludes Step 5.